5 minutes of your time and you'll not regret it. Let's jump in. Open your Excel. I want to show you a few things. I have data here for 20 people who are in a trust taking loans and they have also shares in the same trust. Now we have the amount of shares that is given by each and every of these individuals, and we have the loan limit that they also took. Now I want us to get sense into these numbers, and having them this way would not really help in anything. Let me show you something here. How would you relate the amount of shares and the loan that somebody has? What's the relationship between, if I have this amount of shares, then this is my loan? What is the possibility of me paying back my loan, and what's the possibility of me having higher loan limits as opposed to other people with either high or low amount of shares? Now what happens here is a simple relationship between these two variables. We have loans and we have shares. I want us to run a simple linear regression for this set of data. Then I'll explain a lot of things as we are going forward. Quickly, first things first, let's first of all install a data analysis tool for Excel. If you haven't done this, and if you haven't done such sort of analysis, kindly head into your file, go to more options and click options. A dialog box will come in. On your left, select add-ins, and you will be listed for the add-ins that we have in Microsoft Excel. I want us to specifically to take analysis toolpack, the first one here. If you click it and head down and click go, it will bring up a dialog box. Now kindly check, ensure that analysis toolpack is checked. You can check all these as you want, but with preference, and checking analysis toolpack alone, you're good to go, and click OK. That will bring a toolpack for you in your analysis. Now I want us to head to our data tab, and in the data tab here, kindly on the far right, click on the analyze group, click data analysis, and after a dialog box pops up of analysis tools. Now I want us to choose regression, as I had told you earlier, regression here, and click OK. Now we have a regression dialog box with us. We have input, we have output, then we have normal probability. I'll not go into much of these statistics, but I want to tell you what an input range is, and an input y range is, and an input x range is. Now in data, we know that x and y are variables. Now one variable depends on the next variable. For example, in the data we are dealing with, loans and shares, the amount of loan you can take depends on the number or the amount of shares that you have with the trust or with the circle or with the company. Now if, for example, I have a shares of 75,000, what is the amount of loan that I'm able to take for that case? Now y is a dependent variable, x is an independent variable. Y depends on x. That makes y dependable. A lot of x and y, I'll not get into that, but very simple. Know that y is a dependent variable and x is an independent variable. Now x explains how y behaves. In other words, your shares in a company tells of how your loaning and loaning stuff behaves. Let's go. Input range y, I want us to choose, we may have a lot of factors in, for example, in a bank or anywhere, that establishes your loan limit or your credit worthiness. You know, it may depend on the amount of shares you have with that company, or it may also depend on your ability to pay the loans that you take in a company, so that your credit score either goes high or low. Now on the input range, let's click on the upward facing arrow, then select the loans. click, hold and drag to the last person, 20. Don't include the total. On the input X range, come over again and click on shares down to the last person. After you've done that, as you can see, we have labels of our data. We have ID, we have loan, and we have shares. Ensure this checkbox for labels is checked to ensure that Excel establishes that the first row of your data are labels. Now, after that, we are going to have our input in a new tab. And I want also to have some residuals. I'll explain what residuals are as we go forward. Let's click OK and see what happens. Magic, boom, we have it. Now we have an output summary here. It's a lot of sweet statistics, which I'll want to explain one by one. We have multiple R, we have R squared, we have adjusted R, we have standard error and observations. First things first, from known to unknown, observations are the total number of people in that company who are saving with them and who are also taking shares at the same time. There are 20 observations, 20 individuals. Now, multiple R, we are looking at a relationship between loans and shares. Multiple R describes how strong a relationship is between shares and loans. And for this case, we have 0.59. In percentage, this one is around 59, not really 59, but 0.59 mean a positive value of relationship. Now, loans and shares in this company relate to each other positively, and the other term for multiple R are correlation coefficients. Correlation coefficients, don't mind about these, and you really need not to worry about this. It's a simple stuff. It ranges between -1 and 1 positive. Now, between -1 and 1, we have 0 in the middle. So as it tends to -1, the relationship is weak. Now, if as it moves from 0 to +1, the relationship becomes strong. And that tells you that now that our multiple R value is 0.59, it is positive. We have a slightly strong positive correlation between shares and the loans that somebody takes. Now, R squared, now this is interesting. R squared is 0.35. R squared explains the total, the amount, it explains the value that can be explained by a variable. In other words, if you're told that we have 35%, 0.35, that is around 35% of the values that we have as loans. 35% of all loans that were taken by individuals in this company are explained by the amount of shares that we have. So in this model, all loans that were taken, 35% of them were explained by the amount of shares that somebody has. Now, adjusted R may not be really relevant here, but again, I just want to mention adjusted R is used when we have multiple variables. Multiple variables, I mean, if we had, if we had shares, we had credit score, we had a lot of things, geographic location, economic activity that somebody is doing and stuff, a lot of those variables in relation to the amount of loan they have. If we had all that, then we would adjust the percentage of loans that could be explained by all those variables. Get it? Fine. Standard error is just an error. For this case, we are told that the standard error is 27,327, and that only means that the data points are 27,327 far from the regression line. Now, if we have an average of the amount of loans that are taken by individuals, now how far from the average is these figures. Now, a standard error, it's either positive or minus. You're either 27,000 shillings far away from what it should be in this model. As I had said, observations are just the total number of people. There are a lot of figures here, very interesting. ANOVA is analysis of variance. An analysis of variance, for this case, I'll only explain the F and the F statistic. This only means a significance test. Significance test, I mean that this model is significant. Is significant by these, I mean that it is less than 0.05. An F value of less than 0.05 renders this model or this test statistically significant. I mean, and these we do not throw out and assume that everything is okay. It is telling us something, it's telling us that, hey, look, there is something significant you need to check here. That's F statistic. It also applies to p-values, and I'll talk about that in a while. Now, degrees of freedom, I may make a video for degrees of freedom and tell you what it is, but I want to tell you briefly about the bit here on intercept and coefficient, and how to now get to the real thing of knowing how your loan is affected by your shares. Now, we are told that the coefficient here for the shares is 0.76. We have a standard error of 0.24 and a p-value of 0.005. As I had said, that p-value tells us that this model this test is statistically significant. Now, we all know, not that we all know, but these are a simple regression formula of y is equals to bx plus a. Some other books call it y is equal to mx plus c, where y is the dependent variable. For our case, it is the loans that somebody is taking. Then b is a coefficient, and coefficient is it's a coefficient, as I said, and x is the shares that we have. For example, ID1, person 1, the model has predicted that he's able to get a loan of 67,446.145. Now, residual here is telling me a value of 25,953.85. What does this mean? It means that this model is able to predict that person 1 should have a loan of 67,446 plus 25,953. Now, these are positive value on top of the predicted value. Now, our model is predicting the amount of loan that you should take less this one. It's giving a residual of around 25,000 of the amount that it can predict. You can see some other values here are negative, to mean that if the model predicts that you can only get 10,000 as a loan, then the residual also indicates negative 10,000. You mean you should not take any loan, you don't merit any loan. Now, that tells you of how powerful this prediction is. Now, we can describe how well our model is able to predict the amount of loan that we can have or we can take in a company. Now, if we have several factors that are affecting the amount of loan that you can get, then we are able to plug in those factors into this model, and it's able to tell you what percentage of those factors are explaining the amount of loan that you can get. Now, it's also telling you what are the relationship between all those factors and the outcome that you want. What is the relationship between shares and your credit score and your occupation and stuff against the amount of loan that you can take? This is a very powerful tool, and I hope it's a very powerful analysis. If you have any question, don't fear dropping it in the comment section below, and I'll be willing to do videos of these so that we all understand how to really make decisions that are informed with the data that we have. Thank you so much for tuning in to this. This is your teacher Moses, and I'll be willing to make sense out of the numbers that we have daily and experience daily. Otherwise, thank you and bye bye.